Hello everyone, and welcome to page 3 of our chapter 8 study guide. This is where we'll actually start to go a lot faster because this is where we started flying, because we learned those triangle proportionality theorems with parallel lines, with triangles, and finding missing pieces. And so if you need help on that, go back and look at our last set of notes. It was 8.4, but we're going to solve for the indicated value. The first thing I notice is that I have a line that is parallel to a side of a triangle. So that means that what happens is this gets cut proportionally. So the way that blue relates to yellow will be the same way as blue relates to the yellow on the other side. And so we said this kind of looks like an equal sign. Like the way I picture this is when I go to set this up, I can kind of see that, okay, if I put an x here, x over 3 should be equal to the way that 4 relates to 2. So 4 over 2. So I get to just cross multiply and solve here. Whenever I cross multiply, I get 12 equals 2x. And so when I have 12 equals 2x, after cross multiplying, you divide by 2 on both sides and you get 6. So let's go back and plug that in, make sure that makes sense. If x is equal to 6, then 6/3 is 2 over 1. 4 over 2 is 2 over 1 as well. And so this triangle was split proportionally by this parallel line. Now, number 36 is a little bit different because it's got an angle bisector in a triangle, and we learned that there was an angle bisector theorem that said the way that this blue relates to this pink on the left is going to be the same as the ratio as 6 to this pink, that third side that gets split. So on that pink piece, I'm going to put an x. And so 6 over 9, that fraction, should be equal to the ratio of x over 6, which is the fraction on the right. So again, I'm just going to cross multiply and solve. When I do that, I get 36 equals 9x. So x is going to be equal to 4. Let's plug that in and make sure it makes sense. If x is 4, then 6 over 9 is 2/3, and 4 over 6 is 2/3. So you should know before you even turn in your test on Friday if you got it right or not. Go back and plug it in and check yourself before you wreck yourself. Okay, so now I've got more proportionality, but I've got it across parallel lines instead of across triangles. So it's whenever we've got the 3 parallel lines, that says, and we've got 2 transversals, that says that the way that this 5 relates to this x plus 2 should be the same ratio as this 3 over this 6, that 1:2 ratio. And so let's set that up. That would be 5 and 3. I use these parallel lines kind of like an equal symbol. And that should be in the same ratio as 5 over x plus 2. I'm going to put that in parentheses as 3 over 6. So again, just cross multiplying. Y'all are used to this. 5 times 6 is 30, and that's going to be 3 times x plus 2. So we got to use a little bit of distributive property on this. Come see me if you need help on that, but that means that x is 8. Let's plug it in and make sure that that makes sense. So if x is 8, that would be 8 plus 2. 8 plus 2 is 10. So 5 over 10 is 1/2. 3 over 6 is 1/2. So I know that I'm doing good math there. Okay. Why can I use the triangle proportionality theorem? Because I've got a side of a triangle that is parallel to this middle segment. And so what that does is it cuts this left side the same ratio proportionally that it cuts the right-hand side. And so what I get to do is I get to say, okay, well then that means that 4 over 2x plus 4 is going to be the same ratio or equal to the way that the 3 on the right divides with the x plus 7. So again, I've got to use cross multiplying. I'm going to be doing 4 times that whole amount. I'm going to be doing 3 times this full amount. So that is going to be using some distributive property. So that ends up being 4 times x plus 7, distributive property. Sorry, y'all, that's my kids. And then 3 times 2x plus 4. It is nap time, but they are not napping. We've had some snow days recently, so they're not tired. Okay, so then that ends up being 4x plus 28 equals 6x plus 12. And whenever you do all that math, you end up getting x is equal to 8. Let's double check that, make sure that that makes sense. If x is 8, this would be 2 times 8 plus 4, that'd be 20. So 4 over 20 is 1/5. And then this would be 8 plus 7, which is 15. 3 to 15 is also 1/5. So I know that I'm doing good math there. I know that what I'm doing makes sense. Okay. So again, we've got these. This side is parallel to this side, so this gets cut proportionally. So there's a few different ways to do this problem. What I'm going to do is I'm going to find the pink piece because I'm used to working with that smaller piece, and so I'm going to do 82 minus 28. So what is left for right here? 54. So now I don't need the 82 anymore. I found the 54, and so that's going to be 28 over 54 should be equal to the ratio of 2x plus 8 over 5x minus 4. So again, we're just going to cross multiply and solve. I'm going to throw this in parentheses because that helps me out. 28 times 5x minus 4 is equal to 54 times 2x plus 8. Come see me if you need help on any of that math, but you end up getting x equals 17. And let's check ourselves. 2 times 17, if I plugged this in, would be 2 times 17 plus 8, which is 34 plus 8, which is 42. Then we're going to do 5 times 17 for the pink part. 5 times 17 minus 4. So we're just checking ourselves. I want y'all to do this on test day as well, so make sure that you're slowing down. It's not about speed. It's about seeing that our answers make sense and checking for 42 over 81 and checking for a logical answer. So 42 over 81. 42 divided by 81 is 0.5185. You could simplify that as a fraction, but if you do 28 divided by 54, you get that exact same thing, 0.5185. You could simplify those, they're going to be the same fraction. Okay, so I know that my answer is a good answer and it makes logical sense. Okay, on this problem, they have turned our parallel lines vertically, which is totally fine. And we've got a set of 3 being intersected by 2 transversals that are different. But the way that they get cut off is going to be proportionally. So when I go to set this up, I like to use colors. This helps me a lot. I kind of turn my head sideways. 36.4 over x is going to be in the same ratio or equal to 28 over, oh, I don't know this little small blue piece, so I need to find it. 49 minus 28 is going to give me 21. So now I don't need the 49 anymore. And then I'm just going to cross multiply and solve. For 40, when I cross multiplied, I got 6. So if you need help on that, come see me. Okay? Does that make sense as an answer? You can type it in and see. You could cross multiply it again, or you could just see that those reduce to the same fraction or decimal. Okay? All right, now I've got an angle being bisected in a triangle. So again, the full amount to the smaller third side that got split in half is going to be in the same ratio as this full amount to this smaller amount. So I just kind of use that to help me set this problem up. And so that would be 35 on top. The ratio of that over the smaller piece, 25, is going to be equal to the ratio of 4x minus 14 over 30. How did I get 30? I did 55 minus the 25, and so that gave me my smaller piece. And I get to set those equal. I'm going to throw this in parentheses, and I'm going to cross multiply and solve. For the purposes of making this video not last forever, because life is short, I'm going to go ahead and tell y'all that x is going to be equal to 14. So if you need help with that, come see me. And that does make sense as an answer when I go back and check the math on it. Okay? All right, now 42. Let's slow down a little bit once we get to 42. 42, I've got the 3 sets of parallel lines being cut proportionally. There's blue and blue. Now this is interesting. This is 55, which is both, and then 7x plus 2, which is both of those pieces. When I say both of those pieces, I mean these 2 segments added together. Okay? So now I get to say that the way that the blue, so let me change colors, the way that this blue, 20, relates to that pink, 55, on the top, is going to be in the same ratio as 20 over this one, 7x plus 10. Those should be equal. So again, I'm going to throw this in parentheses. I'm going to cross multiply. I'm going to be doing 20 times 7x plus 10. I'm going to distribute that 20 to both pieces. Equals 55 times 20. 55 times 20 is going to give me 1,320. And I end up getting x equals 8. 7 times 8 is 56, plus 10 is 66. 24 over 66 is going to be the same fraction as 20 over 55 whenever you reduce those in your calculator. Okay, so number 43, you've got some choice in how you work this one. Oh, that's not a highlighter. Here we go. Let's change it. This is a highlighter. I've got a line that is parallel to the third side. And so the way that this piece relates to this piece is going to be the same way that this piece, pink, relates to this piece, blue. The problem being that I do not know what the smaller pink piece is for this one. So a few ways you can work this problem. I'm going to do it kind of how we did it in class, just to mimic what we've done, but I'm also going to show you another way because many of you thought outside the box when you got to this problem, and I loved it. And so this triangle is getting cut proportionally. So let's say you did the small pieces. I could do 35 over 15 for this bottom piece. And that should be equal to the ratio of pink, smaller pink, to blue. So what is my smaller pink going to be? Over blue, which is 3x. My full amount is 60. So this expression for this one is going to be 60 minus what I've already spent for blue, which is 3x. 60 minus 3x. So you could do it this way. You'd cross multiply and solve. When you cross multiply and solve on this one, you get x equals 6. But many of you in class recognize that, okay, well, I have the full amount here. So if I wanted to make that, let's color code it. What if I wanted to make that green? I could just find the full amount here, which is really easy to do because that's simple math. 35 plus 15 is 45. So what I could do is I could use the blue pieces. Let me change colors. The blue pieces, 3x over the green piece, 60, should be the same ratio as the blue piece on the other side, 15 over the full amount. Oh my gosh, why did I write it that, y'all? 35 plus 15, I wrote 15. That's not what I meant to say. 35 plus 15 is going to give me 50. I don't know why I wrote that other thing. Here we go. So that should be 50. So 35 over 50. When you cross multiply, you would get 150x equals 60 times 15. When I do 60 times 15, I get 900. And then 900 divided by 150 is still going to give me 6. So there were two different ways to do that. And many of you in class worked at different ways, but y'all still got the same answer. That's what I love about math. Different approaches will still allow you to get the same answer. Okay, last part. Use the figure at the right to complete each proportion. So I notice I have 1, 2, 3, 4 lines that are parallel. How do I know they're parallel? We've got those triangles, which means that the way that these segments are being split off is going to be proportional. So I'm just going to color code each of these pieces. Let's go gray. So I've got the blue piece to the pink piece and to the gray piece. Okay, so two different transversals. So I see this as colors. So it says A over C. So A is a blue piece on the left transversal. The way that that relates to the pink piece in the left transversal should be the same as what? So A to C. I'm sorry, y'all, that should be gray. A to C. Y'all can tell we've had a few days off because of weather because I'm struggling. A over C would be the same ratio as what over F. So that's going to be the blue piece. What is the blue piece on the right? That is going to be side D. Side D. Okay? All right, now let's do that again. It says F over E. So F over E is the transversal on the right, which is gray over pink. So that's going to be equal to transversal on the left, C over what? That is going to be B, which is another pink. It's another pink. Okay? All right, E over F, that is going to be pink over gray again. That's equal to what over C? That is going to be B. B over C. So we're just filling in missing pieces is what we're doing here. Okay? Let's keep going. A over what is equal to B over E. So this is interesting because now it goes pink over pink, left over right. So it's saying A, blue, over what's the blue on the right? That would be D. D. Okay? Now they go A over B, which is blue over pink on the transversal on the left. So let's mimic that on the transversal on the right. What over E? That would be D over E. So we have a whole bunch we're filling in D for a lot of these. D over E. Okay, last but not least, F over C, gray over gray, right to left, will be the same as E, which is pink on the right, over what is pink on the left. That would be B. B. So I'm going to pause here, and then I'll make page 4.